The letters A to D in the table below represent 4 organic compounds that belong to different homologous series. Whenever we are doing organic chemistry, these type of questions, we're not going to look at the questions. First, we are going to look at the information that is provided and then try and change everything into its structural formulae and then name whatever is not named. Let's start with A. We have 2-methyl propanol. The al at the end means that it belongs to aldehydes, and then the parent chain has a prop prefix, so that means the parent chain has 3 carbon atoms. And then on carbon number 2, I have a methyl group. So that's a methyl group on carbon number 2. And then the functional groups of aldehydes, we have the carbonyl group at the terminal carbon. And then that's what we have. So that is 2-methyl propanol. And then now we are going to look at B. So we are given that in structural formulae. The only thing that we need to do is to identify which homologous series does it belong to, and then from there we are going to name it. So that is a carboxylic acid, and we can see that by that right there. That gives us the functional group of carboxylic acids. Okay, and then now we are going to name it. The first step in naming it is to identify the longest continuous chain, ensuring that the functional group gets the least possible number. Okay, so what does that mean? I can number from 1, 2, 3, 4, 5. That is the longest continuous chain. Even if I number in this direction, I am still going to have 5 carbons, so it doesn't make any difference. Okay, now I can also number 1, 2, 3, 4, 5. So we said that the functional group must get the least possible number. When you're looking at the red color, the functional group sits on carbon number 5, but with the black pen, the functional group sits on carbon number 1. So the correct numbering will be the black one. Okay. Step number 2, it is to identify any side groups. So we do have side groups. We have that ethyl group, and then we also have that methyl group. Okay, done. Okay, so now we need to start naming. So we're going to name the side groups in alphabetical order. So the ethyl group will come before the methyl because E comes before M. And then we have the ethyl group on carbon number 3. So this is going to be 3-ethyl. And then we have the methyl group on carbon number 2. And the parent chain has 5, it consists of 5 carbons. So that is pent. And then the functional group, that's carboxylic acids. So it is going to be pentanoic acid. Moving on to C. That is obviously an alkyne because we have a triple bond there. Okay. The first step is to identify the longest continuous chain, ensuring that the functional group gets the least possible number. 1, 2, 3, 4, 5. Or it can be 1, 2, 3, 4, 5. So it is clear to see that the functional group sits on carbon number 3 when you are numbering using the red pen. It sits on carbon number 2 when you're numbering using the blue pen. So we are going to use the blue pen. So this, we don't have any side groups. So we are just going to use the parent chain to name. So we have 5 carbons. So this is going to be pent. And then on carbon number 2, sorry about that. So we said that we have pent because the parent chain has 5 carbons. And then on carbon number 2, that is where we have the functional group. So this is pent 2 ine. Okay. For D, we have pentane. The ane means that it belongs to alkanes. So we have 5 carbons. That's the structural formula of pentane. And of course, we have hydrogens. Okay. And then now we can start answering the questions. 2.1. Define the term homologous series. So this is a group of compounds that belong to the same functional group and have the same general formula in which the members differ by a CH2 group. Okay. 2.2.1. Write down the letter that represents a saturated hydrocarbon. Saturated means that we have only single bonds between the carbon and the hydrogens, and that can only be alkanes. So that is going to be a D. 2.2.2. The general formula of the homologous series to which compound C belongs to. That is an alkyne. Alkynes have this general formula. Let's just say that you don't know the general formula for the compound that you're given. What you do is simply just go and count the number of carbons that you have. So it's 1, 2, 3, 4, 5. So you have C5. And then the hydrogens, you have 3, 5, 8. So you have 8. Okay. Then what you do, you set up this Cn. And then right there, you can have, so it looks like this, right? So what you're going to do, you're going to say you have 5 carbons, so that is Cn. And then look at this, you have 8 hydrogens. So instead of a 2n, you have a 2n minus 2. Because if you had a 2n, you would have 5 carbons and 10 hydrogens. But in this instance, you have 8 hydrogens, so you're just going to subtract 2 there. That's how you get your general formula. And this is true for any other organic compounds, whether they belong to alkanes, whether they belong to carboxylic acids. You can do the same thing to find the general formula. 2.2.3. So we need to write the structural formula of compound A. We've already done that. There it is. And then 2.4. Compound D has 3 structural isomers. Write down the structural formula of the isomer with the shortest chain. Okay. Compound D, right? So that's pentane. Okay. That's what we are given. So the isomer that is going to have the shortest chain, I will have 3 carbons. 1, 2, 3. Then I'll have 2 methyl groups there. Okay. And then 2.4.2. I should write down the balanced equation for the combustion reaction of compound D in excess oxygen using molecular formulae. That's pentane, so it is C5H10. Combustion reaction means that I'm reacting that with oxygen, and they told me that the oxygen is in excess, so it is a complete combustion. The product for a combustion reaction, it is going to be carbon dioxide and water. Now I have 5 carbons on my left hand side, so I'm going to have a 5 there, and then I have 10 hydrogens, C5, so I have a 10 hydrogens. So if I want to have 10 hydrogens this side, I need to put a 5 there. So I have 5 carbons on my left, I have 5 carbons on my right, I have 10 hydrogens, and then 5 times 2, that is a 10. So those are balanced. So now I just need to balance the oxygen atoms. So now I have 5 times 2, that is a 10, and then the 5, pentane. Oh, so this is 12. Sorry, this must be a 12 because it's pentane, and then the general formula should look like this. Okay, so that must be a 6, so that I can have 12 hydrogens. Okay, so I have 10 oxygens plus 6, so that is 16. That means that I need an 8 there. So it's balanced. 5 carbons, 5 carbons, 12 hydrogens, 12 hydrogens, 16 oxygens, and then 16 oxygens.